So it says that Betsy has $50,000. So she has 50,000, right? And she wants to have an annual return of 5,000. Correct? So this is what she has. Let me make sure it's in frame. This is what she has right here, and this is what she wants back, right? Furthermore, in her portfolio, she has listed B-rated bonds and CDs, right? The B-rated bonds, I believe it said that it gets an annual return of 13%, meaning if you convert that into a decimal, you just divide by 100. 13 over 100 is 0.13, and we're going to assign that a variable x. The CDs, they offer a lower rate of return. They offer 3%, I believe, right? 3% per year. Divide that by 100, we get 0.03. We got to give it a different variable. We're going to call it y, just so that way we could have distinction between the two investments. So when it says that when she invests, she wants to invest in both of these, such that she gets this in return every year. So we could write a system of equations. One, x plus y, she has to add one portion of the investment and another portion of the investment that equal to 50,000. So it's going to be x plus y equals 50,000. Because this is going to determine how much of each investment needs to be invested so that it doesn't go over her limit, right? So x plus y is 50,000. Furthermore, we need to have 0.13x plus 0.03y equals 5,000, right? Because this is going to tell us how much of each of these should be invested to get that return. So now that we have a system of equations, we could use either substitution or elimination to solve for x and y. So let's go ahead and do that. First, we could try solving for x by dividing everything. Or no, I'm sorry. First, what we could do, what might be easier, x plus y equals 50,000. Right? We could subtract x from both sides. Right? Now we have y equals 50,000 minus x. Now that we have y by itself, we could substitute it and put it back in the second equation. So let's go ahead and do that. 0.13x plus 0.03y equals 5,000. And we're going to plug in this whole thing. Ignore that. We're going to plug in this whole thing right here into that y value. So this becomes 0.13x plus 0.03 parentheses, if I can find my towel, 0.03 times 50,000 minus x equals 5,000. Because we got to keep that there. So all we did here is we manipulated the first equation and got the y by itself, so that way we could plug in the whole thing into y for the second equation to find x. So now that we have that, we could just do some basic math. 0.03 times, you just distribute it, right? 0.03. Alexa, what is 0.03 times 50,000?
0.03 times 50,000 is 1,500.
1,500. Right? Okay, minus, and then 0.03x equals 5,000. And then we keep this right here, 0.13x plus that. So now we have two like terms right here. We can just add those together. 0.13 minus 0.03 becomes 0.10x plus 1,500 equals 5,000. Now we subtract 1,500 from both sides. Alexa, what is 5,000 minus 1,500? That's 3,500.
5,000 minus 1,500 is 3,500.
Bingo. Subtract 1,500 from both sides, we get 3,500 equals 0.10x. Right? Now we divide both sides by 0.10x. Alexa, what is 3,500 divided by 0.1?
3,500 divided by 0.1 is 35,000.
35,000 becomes our value for x by getting x by itself. Now, we have an x value, so basically she has to invest $35,000 into B stock or B whatever fucking B bonds, right? And now that we have x, we could just plug it back into the y, and we can plug it back into the first equation. So 35,000 plus y equals 50,000, right? Minus both, subtract 35,000 from both sides. I don't know if I'm blocking the camera, but. Alexa, what is 50,000 minus 35,000?
50,000 minus
15,000?
35,000 is 15,000.
15,000. I am on a roll today. 15,000 equals y. So in summary, she needs to invest $15,000 into CDs and $35,000 into the B stock bonds by just manipulating the first equation such that we could find one variable and then just plug that same variable back into the others. Let me know if you have any questions.